Student, today we started our class from the discussion electromagnetic waves. Okay, students, light radiations are regarded as having a dual nature, that is wave nature and as well as particle nature. Okay, so electromagnetic waves, those waves which consist of oscillating electric and magnetic fields. And electric and magnetic field components have the same wavelength and frequency and travel in planes perpendicular to each other and also perpendicular to the direction of propagation. Okay, and electromagnetic radiations, those radiations which are associated with electric and magnetic field are called electromagnetic radiations. All of them move with the same speed regardless of their wavelengths. Okay, and they travel at the speed of 3 into 10 to the power 8 meter per second, which is called speed of light, and it is denoted by c, small c. Okay, student, wave number, it is reciprocal of wavelength and it is defined as the number of waves in 1 centimeter or 1 meter length, that is per unit length. Wave number is a reciprocal of wavelength. It is defined as the number of waves in 1 centimeter or 1 meter length, that is per unit length. Okay, and wave nature, a wave is spread out in space. A wave is spread out in space and two or more waves can exist in the same region or space. When two waves are present together, their resultant wave can be larger or smaller than the individual waves. In simple words, wave is delocalized and two waves may interfere. Their interference may be constructive or destructive. Okay, now student, we discuss our next topic, that is Planck's quantum theory. Okay, Planck's quantum theory. Students, according to this theory, the energy is radiated or absorbed by a body not continuously but discontinuously in form of small packets. The energy is radiated or absorbed by a body not continuously but discontinuously in a form of small packets. Each packet is called quantum. In case of light, the quantum is called also photon. Okay, and the energy of quantum is directly proportional with the frequency of the radiation. The energy of quantum is directly proportional to the frequency of the radiation. If frequency denoted by nu and quantum energy of quantum expressed by capital E, then we can say that E proportional to nu, that is E equal to h nu. Here h is Planck constant. Its value we know that 6.626 into 10 to the power minus 34 joule second. And then we can once again express energy of quantum as hc by lambda, because we know that nu equal to c by lambda. So we put here in place of nu the value c by lambda. So E becomes hc by lambda, where c is the velocity of light and lambda is wavelength. Okay. So, in Planck quantum theory there is a limitations also. It is Planck could not explain why energies should be quantized in this manner. Okay, and he could explain the distribution of intensity in radiation from a black body as a function of frequency at different temperatures with this assumption that energies are quantized. Okay, student, we discuss about photoelectric effect. It is the phenomena in which the surface of alkali metals like potassium and cesium, which have low ionization energy, emit electrons. And when a beam of light with high frequency made to fall on them. Okay, so what is photoelectric effect? It is the phenomena in which the surface of alkali metals like potassium and cesium emit electrons when a beam of light with high frequency made to fall on them. Okay, the ejected electrons are called photoelectrons. It helps in explaining the particle nature of light. Okay, and experiments have shown that electrons are ejected from the surface of certain metals like cesium, rubidium, and when they are exposed to light. Okay, and according to the wave theory, both number of electrons ejected and their energies should depend on the intensity of the incident light in particle. It is found that while the number of electrons ejected depends upon intensity of incident light, but their energy do not. Okay, student, particle nature of light. The observation in photoelectric effect that the number of photoelectron ejected is directly proportional to intensity of incident light showed that light consists of particle called photon moving with speed of light. They strike the electrons and photoelectrons are ejected, that is E equals to h nu. Okay, using the Planck's quantum theory, the particle nature of light, the observation in photoelectric effect that the number of photoelectron ejected is directly proportional to the intensity of incident light, which showed that light consists of particle called the photons moving with speed of light. They strike the electron and photons are ejected. So E equals to h nu. Okay. Now we discuss about spectrum. It is the combination of light of different wavelengths. For example, when light passes through prism, series of color bands is obtained called the visible spectrum. It ranges from 8 into 10 to the power 14 Hz, which is violet light, to 4 into 10 to the power 14 Hz, which is red light. Okay. Now we discuss work function. It is the minimum energy required to eject an electron from a metal. Okay. It is equal to h into nu 0. It is also equal to ionization energy. So work function is the minimum energy required to eject an electron from a metal. Okay. Now student, we discuss Heisenberg's uncertainty principle. Okay, Heisenberg uncertainty principle states that it is not possible to determine the exact position and velocity simultaneously for a subatomic particle like electron at any given instant to an arbitrary degree of precision. Consequently, it is not possible to talk of path of the electron in which it moves. So, according to Heisenberg's uncertainty principle, it is not possible to determine the exact position and velocity simultaneously for a subatomic particle. Okay, so according to Heisenberg principle, uncertainty principle, which states that it is impossible to determine simultaneously the exact position and exact momentum or velocity of an electron. Okay. And significance of uncertainty principles are that it rules out existence of definite paths or trajectories of electrons and other similar particles. Okay, and the effect of Heisenberg uncertainty principle is significant only for motion of microscopic objects and is negligible for that of macroscopic objects. Okay, orbits and orbitals. Orbits, it is a circular path proposed by Bohr around the nucleus in which electron revolves, and it has maximum electrons equal to 2n square, where n is a orbit number. So in each shell or orbit, maximum electron holding capacity depends on the formula 2n square. Okay, when n equal to 1, maximum electron holding capacity in first shell 2 into 1 square, that means 2. So 2 electron can be present on the first orbit. Okay, and when n equal to 2, that means in second orbit the maximum electron holding capacity is 2 into 2 square, that means 8. Okay, in this way we can find out the maximum electron holding capacity in or each orbit, and its name started from capital K, capital K, capital L, K, L, M, N, and so on. So we can naming these orbits with a name K, L, M, N. Okay, and orbit is circular in shape. It is not possible according to Heisenberg's uncertainty principle. Okay, and orbital, atomic orbital is the region or space where there is maximum probability of finding electron. Student, atomic orbit is a circular path which proposed by Bohr around the nucleus in which electron revolves, and atomic orbitals is the region or space where there is maximum probability of finding electron, and it has maximum true electrons. Different orbitals have different shapes. Okay, and it is according to quantum mechanical concept denoted by the wave function phi in an atom. Okay, now student, we are discuss about quantum numbers. Okay, Student, atomic orbitals can be specified by giving their corresponding energies and angular momentum, which are quantized. That means they can have the same specific values. The quantized values can be expressed in terms of quantum number. Okay, and they are used to get complete information about electron, that is location, energy, spin. Okay, there are four types of quantum number. First one is principal quantum number, then angular quantum number, magnetic quantum number, and spin quantum number. Okay, so principal quantum number, it specifies the location and energy of an electron, and it is the measure of the effective volume of the electron cloud. Okay, and it is denoted by n, small n. Its possible values are 1, 2, 3, 4, and so on, and its name of course started with capital K letter, that is K, L, M, N. Okay, so angular momentum quantum number is also called azimuthal quantum number. The quantized values of orbital angular momentum can be specified in terms of the angular momentum quantum number. It determines the shape of the orbital. Okay, and it is denoted by small l. And the permitted values of L are 0, 1, 2, okay, up to n minus 1, small n minus 1. So L can be value equal to the 0 unlike n. Okay, the maximum value of L is equal to n equal to minus 1. That is, if the value of n equal to 6, then L will be have the values 0, 1, 2, 3, 4 and 5. And it represents S, P, D, F, G, U orbitals. And these S, P, D, F, G, U are small letters. Okay, student. Now, magnetic quantum numbers. An electron having angular momentum produces a magnetic field which can be observed. The observed magnetism shows the quantized nature and is described by the magnetic quantum number, and it is denoted by ml, small m and in suffix l. Okay, and its value depends on the value of L, that means angular momentum quantum number. Okay, and since magnetism is due to the angular momentum, it determines the magnetic orientation of an orbital, that is the direction of orbital relative to magnetic field in which it is placed. Clear? And its permitted values are minus L to plus L, including 0. When L equal to 1, then M will be minus 1, 0, plus 1. Okay, and its total number of values equal to 2L plus 1. Okay, now spin quantum number. It indicates the direction in which electron revolves. Spin is magnetic property and is also quantized. It has two permitted values, that is plus half and minus half, and it is denoted by small s. So spin quantum number indicates the direction in which electron revolves. Okay, student. Now student, we discuss about Pauli's exclusion principle. Okay, Pauli's exclusion principle. According to this, Pauli's exclusion principle, according to this, no two electron in an atom can have the same four quantum numbers. It can also stated as an orbital can have maximum two electrons and they must be opposite spin quantum numbers. Students, according to Pauli's exclusion principle, no two electrons can have the same four quantum numbers. Okay. It can also be stated as an orbital can have maximum two electrons and they must be opposite spin quantum numbers. Okay. Now we are going to say about the Aufbau principle. Aufbau principle. According to this Aufbau principle, electrons are filled in the various orbitals in the increasing order of their energies. Electrons are filled in the various orbitals in the increasing order of their energies. That is, orbital having lowest energy will be filled first. Okay, and the total orbital having the highest energy will be found last. I am saying once again, student. According to Aufbau principle, electrons are filled in the various orbitals in the increasing order of their energies. That is, orbital having the lowest energy will be filled first, and the orbital having the highest energy will be filled last. Okay. Now we state about Hund's rule. According to Hund's rule, no electron pairing takes place in p, d and f orbital until each orbital in the given subshell contains one electron having parallel spin. Okay, so no electron pairing takes place in p, d and f orbital until each orbital in the given subshell contain one electron having parallel spin. Okay, student.